Okay, let's talk about photogrammetry. So, a lot of the time, we need to have some real world information that we need to model off of or put into our renderings. So, what photogrammetry is when you go out and take a lot of pictures of something in the real world, and then the computer processes that and creates a 3D model. For example, you can see this rock wall right here in the rendering. I actually created that. I went out and took pictures of a retaining rock wall near me, and then came inside and put all the photos into this program, and the computer compared all those images to each other and created this 3D model. The way that they do that, you can see here in reality capture, each one of these pyramids represents where the camera was, and it compares multiple points from image to image to create a point cloud. This one is about halfway through processing, and so you can see the points that it's finding. And when it compares it from image to image, it sees how the perspectives are changing, and so that's how it determines the distance from one point to another. And so we often use this with Google Earth because Google Earth is made with photogrammetry. For example, if we go to Salt Lake City, we zoom in here, we can see that there's 3D buildings. And so what they do is they fly planes and take images and process it exactly the same way. And so that's what this is a photogrammetry model. We can turn that off if we check 3D buildings. Now we just have the 2D. Construction companies use this a lot for getting a model of topography. They will fly a drone over a site and they will pre-program a flight pattern into the computer beforehand, and then the drone will fly that path and capture images as it's flying along that path, and then it'll create a real world model for them that they can use for topography. Civil engineers use that a lot. Um, what we're going to use this for today is to get a model from Google Earth similar to this one. This one was done fairly well. You can see the areas that were captured by the camera points. Um, you can see up here that he started by taking screenshots of Google Earth. The camera was pointed straight down. And so what he did is he covered the area that he wanted to capture, looking straight down. And then he came in and started orbiting around the objects, taking screenshots. And that's exactly the correct method for doing it with a drone or screenshots from Google Earth. Another application that I have used this before, um, when we're doing some conceptual renderings, oftentimes I'll go to Google Earth and find an example of the building. For example, this is an In-N-Out, which is a franchise, so we're going to be able to find similar buildings. And so I took screenshots of Google Earth and I brought this model into Revit and was able to use it to create a mock-up for the conceptual renderings for different development. Okay, on this project, I need to capture downtown Salt Lake. So I need these high rises. I actually need to capture quite a large area. So I might break this up into two models. But the first thing that I want to do is press R on my keyboard. And I want to get rid of all words and everything that's distracting. So first thing we're going to do is get rid of my search. When you first open up Google Earth, it'll have these boxes checked until you'll start seeing a lot of stuff. We want to get rid of all of that. The only thing we want to see in our image is the actual mesh. We don't want to see any text, no highlights, or it will confuse the computer. Okay, so if I press R on the keyboard, it'll take my view to look straight down and north will be up. So for the first portion of this, we want to take about 40 to 50 images looking straight down. We want to cover the area that we're trying to capture. So to take a screenshot, we go up here to save image. We turn off all these map options, right? Because we don't want to see any of this text. For example, like the legend, we don't want this showing up in each image. It'll confuse the computer. So take all of this off and set the resolution to maximum. Save the images. So I'm gonna start with a new folder. And I'm just gonna name the first one 1, and the second one will be 2, 3, 4, etc. Typically, when we're doing a Google Earth model of a large area, we have about 300. With something like this, I think I only had like 20 or 22, something like that. Okay. Okay, so we want 50% overlap at least from image to image, especially when doing these first 40 where we're looking straight down. So if you just grab the screen in the middle, bring it down, and then take your second screenshot here, then that will be sufficient. As you go across, you go up and then you go over 50%, and then go back down, take your screenshots. That will help the computer recognize like it's a good comparison to look straight down and then go at a 45-degree angle and compare how much, like, you can see that this building is, you can see this much of the wall, so that tells it how high it is. Once we have the 40 to 50 shots looking straight down, then we go and orbit to the angled shots. These shots need to be about 45 degrees looking at your target. We never want to go like this and capture the horizon. That confuses the computer and messes things up. Okay. So this area that I need to capture, I think I'm gonna do a pretty good chunk of Salt Lake here. I think I'm gonna capture this much where we have multiple stories in the buildings, and then I'll leave out this residential area. I do want to capture all of this, so I'm gonna have probably, I don't know, 600, maybe even up to 900 images. Because what I want to do is get a pretty decent model out of this. So when I come down to the 45-degree angle screenshots, I want to capture probably 20 at least around one block. And then I want to come over to this block and orbit it and capture about 20 screenshots as I orbit. Um, just something to consider. If you don't, I mean, if you don't see all sides of these faces as you're orbiting, then the computer won't be able to create the model like this. So just be sure that you're capturing everything. There's a lot of stuff going on here. There's a lot of holes that need to be fully developed. And so the computer needs a lot of images around things like that. Um, Generally, we need about 20 images around a block, but depending on how much is going on in that block, we may need more. So you would just keep orbiting each block until you've covered every block. So we'll have a combination of the angled images and the ones looking straight down, and that will be sufficient to create a really nice model with exactly the same quality as this, because this is a photogrammetry model, and so the computer will create exactly what it has before if you've captured enough screenshots. So there's a little review on photogrammetry. There's a ton of applications that we will use for the kind of work that we're doing. So I think that this is the easiest exercise to start and to learn what you're doing when doing photogrammetry.